Good afternoon, Ananda. My name is Suresh. Sorry for the delay. We have some technical problems here. So today we are going to learn about. Is there any chart? Can you hear us? So today we will learn about data structures. The course, this workshop is entirely divided into four parts. Among the four parts, today we are going to look at in session 1, which is again divided into 3 parts. First we will talk about the course and the limitations of the course and the style we organize the course. In the second part, we learn about complexity analysis, arrays and linked list. In the third part, we learn about stacks and queues. At each session, we will be having a 5 minutes break. What are the course objectives? Just a minute. A director wants to speak to you.
Good afternoon, dear friends. So it's very good to see you all picking up on phase 2, and we welcome you to this participation that we are doing for the first time in a view fashion. Otherwise, all of you would be sitting over here for 4 weeks doing phase 2. So the next 4 weeks, I will just give you the mic in a minute, Sri Venkateshwara, so bear with me. And the whole idea is that we have the colleges come in, and all of you should be able to talk to and see one another and actually get the best benefit of this process. So feel free to ask your questions. And if you have some technical difficulties in terms of a view, then write your message in the chat window, and that would be the process of dialogue. Is it okay? If everybody has understood what I have just said and are ready, willing, and able to participate, type in yes in your chat window. Okay, thank you. From Sri Venkateshwara, I've got a yes. I'm waiting on the other colleges. Ishwar. High Tech says yes. Good. Okay. I'm going to give the mic over to Sri Venkateshwara.
Yes, madam.
You'd like to say something?
Yes, madam.
Go ahead, please. Please speak.
We already completed, madam. 6 sections for all the students in our batch. Already batch started, madam. Started in. Okay, madam.
Excellent.
Thank you, madam.
Very good. Very good.
They are very interested to doing
Wonderful. So
doing the work, madam. We are always monitoring the students how they are.
Very good.
Okay, madam.
Very good.
Thank you.
Very good. Wonderful. So
Yes, madam.
we encourage you to participate well, and you're all
Yes, madam.
comfortable with
They are
this medium?
comfortable. No need to worry, madam.
Okay. Thank you. Thank you. All right. So Suresh has already, started to communicate what the course objectives of data structures are. The whole idea is that you spend just a half a day per week for 4 weeks, and then you will do some work on your own for about 10 to 12 hours. So do plan for that. It was that or be here full time. So this is better, right? Yes? Okay, great. So now the most important thing is that you all know what we agreed on as a culture of participants as we came into enhanced CE the first time, respect for all, being able to respect also the time, right? Being there on time, which means when we're talking about a particular time, then being there and being able to carry it through to the end. And if there's an issue, am I not audible? Hello? Can you hear me? How about now? Can you hear me now? Okay. Okay, great. So, continuing on, I'll turn the mic over to Suresh, who will pick up with DS, and I wish you all the very best and have a wonderful, wonderful phase 2. Enjoy what you do, ask questions when in doubt, and also work on the portal, pose your questions and answers on the portal, and work in the community of the portal. That will further improve your communication skills. Every college that I'm interfacing with after the training program, I'm able to see a wonderful, perceptible advantage and difference in the teachers. So I congratulate you for having successfully completed phase 1 and going on to phase 2. Go ahead and do a wonderful job. Thank you. Bye for now.
Welcome back once again. In this course, what we are doing, the course objective, we will study different tools which are capable of storing and processing the data. Then why do we learn so many different tools? To make a better choice among the tools so that we can choose the best tool that will do the necessity in a reasonable amount of time. And how do you say you made a better choice? Just by doing a formal reasoning, like analyzing its complexity with respect to its input and the other reasons, so that you can clearly communicate your idea why you choose a particular tool. So, what is a data structure? A data structure is nothing but a way of storing and organizing the data so that we can process the data in an efficient manner. There are different types of data structures which are suitable for different kinds of applications. Some data structures are highly optimized, such as hash tables, which are mainly used in implementing a symbol table in a compiler design. We will look at an example, and B-trees, which are more suited in implementation of database designing for indexing purposes. You all know about the databases, right? So let us look at an example of how we implement a symbol table using a hash table. Let us consider a code on the left hand side. If you consider main as level 1, main block as the level 1, and the inner block, second inner block as the second level of scope, and the third one is a third level of scope. If you declare int HAL, if you declare int HAL, the compiler first calculates hash value of H, A, and L. We will talk about the calculation of hash value when we deal with hash tables. For right now, it is a function which returns an integer value. So if you calculate hash value for h, it will be given some integer. It is mapped into the hash table based on that integer. If you see here, h given a hash value, so it is mapped to certain block here, and we keep that in the memory such as h of 1, which says that it is in the scope of main. Similarly, we will keep a and n. If you try to declare another variable like float h here, what it will do? It will calculate the value of hash value of h again, and it will check the hash table. If it is already in the hash table with the scope 1, then it will result in a duplicate error, compiler error, duplicate variable declaration error. So if we declare a float variable in the second scope like float x, y, h, here h is used here only as a float. We can't refer the integer h here. In the second pass, we can see that hash value for h is mapped to the same block, but we have stored it as a scope of 2, h of 2 in the list. Similarly, for the third block, it will give like A3. So, I guess you understand the symbol table implementation. This is a basic idea behind the symbol table implementation, and to be fact, it may be more complex. Next, we look at what are the different operations. How do you choose? Like we have, just a minute. So the course is organized in such a way that section 1 will deal with complexity, arrays, linked lists and queues. Then in section 2 we will deal with searching and sorting. Then in section 3 we will deal with dictionaries, trees and hash tables. In the section 4 we will deal with queues, priority queues. We will learn some these classical data structures using some scenario based applications. Now let us start our discussion of complexity analysis and arrays and linked list. What are the learning objectives? By the end of this part of this section, you will be able to calculate the complexity of a given algorithm. And what are the prerequisites for this complexity analysis? Is you should know some basic mathematics like sets, algorithms, series, modular arithmetics, and exponents. Once you know all these things, you need to have an idea of object-oriented concepts, because we are going to implement the data structures in Java, which is a hooks-based language. Then this is the prerequisites for this course. How do you pick right data structures for your need? See, while considering a data structure for your need, you should think of about the operations that your application needs. So let us consider what are the applications that we can do actually. Let us consider example like adding 2 plus 3. What we will do generally, we will store 2 in a variable and 3 in another variable, and we will do an arithmetic operation in these variables, and we will store the result in another variable. This is adding operation. So what we have done is, we have inserted 2 into a variable, we have inserted 3 into another variable, and we have calculated the sum arithmetic operation on these 2 variables and store the result in another variable. Similarly, we consider another example of deleting a name from a list. First, we need to check if the list contains the name or not. So, what are the common operations that we do in every data structure? is insert, delete, find and search. Find or search. So ideally every data structures that we deal will have all these operations. Then why do we learn different data structures? Here comes the efficiency. What is this efficiency? Consider if you are building an application for mobile application. If you consider a mobile application, mobiles will be having a lower space and less processing speeds. So you need to consider these complexities like space complexity and the time that the application have to be done. And consider another example of banking application where if you go and deposit some amount into your bank account, so if the account goes will be updated in 2 days, then what will be the use of that application? So based on the application that we use, that we build, we need to select the data structures. Just a minute. Okay. Let us carry on. How do you identify the right data structures? For example, in the last slide we have studied the different applications based on their necessities and based on their processor speeds and all those things. We have said that we need to use different algorithms or data structures. Then how do you choose these data structures? How can you say so and so data structure is better than the other? Ideally what we think of is we want a data structure that is fast, elegant and memory efficient. Elegant in the sense it should be simple to understand. So in the real world scenario, if you consider, there are some parameters that needs to be checked for the operations. If you take time analysis, if time versus space. Why did I say time versus space? Because if you are trying to fine tune time more, then we may use the other one like space. It may require more space. Similarly, if you try to fine tune the space of the data structure of the algorithm, then we lose on time. So similarly, performance and elegance, simplicity and the efficiency of the algorithm. And other thing is one operation versus the other operation. Why one operation versus the other operation? See, if you consider there are different types of compilers. If you consider Golang and the Java compiler, they have different instruction sets. So one operation may be better on one processor and compiler, and other operation may be better on the other compiler. So what is this parameters? What is how can we study? The study of these trade-offs between these parameters, what we have seen here, is nothing but the complexity analysis. This is the definition what I have stated now. How do you perform complexity analysis? Let us look at some of the examples that we write in our regular, we'll look at some programs, some basic programs, so that we'll check how we can analyze the complexity. Let us consider a for loop. Let us consider a single for loop. Like you can see that for loop is iterating for n times. In the for loop, we have a statement like arithmetic operation like m is equal to m plus 2. If you consider this thing, m is equal to m plus 2 takes a constant time, and the loop has to run for n times. So the total time complexity will be C is the constant, nothing but m is equal to m plus 2. It must be executed for n times, that is C of n. That is nothing but big O of n. We will study about the big O of n later. We will say that as it is a constant, mostly this function is dependent on n. So we will say it as big O of n. Let us consider a nested for loop. if you have two loops such that one loop is iterating for n time and the second loop is iterating for n time, and there is a similar to the first example, we have a arithmetic increment operation like k is equal to k plus 1, which takes a constant time again. So if you take the total complexity of this nested for loop, so C is the constant time for the execution of the arithmetic operation, n is the inner loop, and again one more n for the outer loop. So which is equal to C of n square. Again, if we consider mostly the complexity depends on the number of iterations, that is nothing but n. So we say it is as big O n square. Now it is clear that if you have a 3 loops, what is the complexity? We can say that it is equal to big O of n cube. So let us look at some other statement, conditional statement like if then else. Here, if statement, in the if we have a logical condition checking. If you consider this condition checking will take a constant time, and then execution of the second part, then part is nothing but a constant because we have only returning a false boolean value. So if you consider this as a constant time, so it will take CO constant time for condition checking and constant time C1 constant time for returning a false. Then it will go for else. Again in the else part we have a for loop which iterates for depth. Depth is nothing but, let us consider it as n because depth is the number of iterations we want to iterate. So if you consider it is n, then in the for loop we have again one if condition which has a logical condition checking, which will take a constant time, and return the false, which also takes a constant time. If you look at the complexity of this if then else statement, C0 is the constant time for checking the first condition, C1 is the constant time for returning the false value, else C1, C2 is the constant time for condition checking in the for loop if condition, then C3 is the return false constant. This C2 plus C3 is executing for n times because these two statements are in for loop. So it will iterate for n times. Then what will be the complexity of this thing? Because we have constant values and all the constant values are is negligible when you consider n, which is going higher and higher. So it will be equal to big O n. So why do we so till now we have studied different equations, right? Different things how to analyze the complexity of a given code. And if you considered or not, we have seen some constants, right? See in the if condition here. This logical operation, we said that the logical operation will take a constant time and the returning a boolean value will also take a constant time. In the previous example, we are saying the arithmetic expression is also taking a constant time. So, all these constant times are all equal? No. It is difficult to say that these operations will take a constant time on all compilers. Is hard to say that we can't say that they will do in a constant time and all the operations with a same constant time. So to do analysis regardless of the compilers and the instruction sets of the compilers and all those things, we'll take these things as a constants so that we can give a general complexity of an algorithm. So what is this? So these assumptions of making constant values and all those things is nothing but asymptotic analysis. In asymptotic analysis, we have different types of notations. In those notations, we will use these equations. We have learned these different equations for different algorithms. So we use these equations in those asymptotic notations. Yeah. Because it's considered as the best analysis or the reasonable analysis. Here we can see a definition for the devotee. Let's read the definition as it is, and we can understand in the next few slides what does this definition actually mean. Okay. Let given two functions f comma g. We say that f of n is bounded by. We are saying bounded by big of g of n. If there exist some positive constants such that c and n naught, such that f of n function should be less than or equal to c of g of n for all the values n greater than n naught. What this is a mathematical function, mathematical thing. We will look it into detail by looking at an example. Right now, what does big O notation give in the analysis? In the analysis, big O notation gives the upper bounds of the given function. Upper bounds of the given function is nothing but f. Let us look at an example and we understand what big O notation is actually. Consider this example. There is a statement, we have seen this already, just there is we have seen this example already, just some modifications. If this condition takes a constant time, okay, statement 1 to statement 99, we take a constant time of 99 C or something else. Summing these two will get a 100 C, okay. Then in another loop we have a for loop, there is a nested for loop. Then we have a condition. If you consider the condition as takes a constant time and this takes a constant time, then what will be the result? 2. This is n square and this is n square. This is constant 1 plus 1. So it will run for 2n square. 2n square plus 2n square c plus what we have checked in the if loop, that is 100 c. If you consider this thing as a function f of n is equal to 2n square plus 100. We have taken the constant out because mostly our algorithms are dependent on the number of input, that is nothing but n. So this f of n is nothing but the function in the big O notation, f of n function. So consider a function, since we are saying that big O notation gives the upper bounds, we will consider an example of g of n as n square, because most of this equation is dependent on n square. We will take it as n square. Now let us find some values so that we can prove that f of n is for a value n greater than n naught, f of n is less than c of g of n. Then we can say that f of n is equal to big O of g of n. From the observation of these two equations, we can say that the constant which we need to start as the function we got as 2n square, we need to start base, it's reasonable to start our c value from 2 or higher than 2. For this example, I have considered c value as 5. So that my g of n becomes 5n square. Then I'll start the n values, submitting the n values like 1 to 8, and I'll give the function what are the resultant values of the functions f of n and g of n. So clearly when we say that n is equal to 1, we can see function f of n is resulting in 1 not 2, and g of n is 5. And 1 at 2, by submitting n2, it is 108 and 20. By going on, at certain point, we will see that g of n value is increasing and f of n function value also increasing, but at certain value, the growth in the function rate of g of n will be more than that of the f of n. Consider the point where value of n is 6, then f of n is 172 and g of n is 180. So after this point, we can see that g of n is growing at a rapid phase, and we can see that f of n values are not crossing the g of n. Let's try to plot this graph. So you can see here, this is the function curve, this is the curve for f of n, this is the n values, x-axis represents the n values and y values represents the number of inputs that we submitted to our algorithm. Then f of n is greater at 1, 2, 3, 4, 5, at 6, both are equal. After that position, we can see, after this point, we can see that g of n is growing at a rapid phase. So that f of n will not cross for any value after 6. F of n will not cross g of n. So that it is bounding the function f of n. So it is bounding at the upper stage. So we are saying that this is an upper bound of this f of n. I think everybody is clear with the thing. If I am going at a faster phase, try to stop, there is no problem, okay? Let us consider other notations. We have seen that big O notation is one of the things in asymptotic analysis. There are other notations like big omega and big theta. We will keep all these PPTs in our portal, and you can study these functions because it is a mathematical function, mathematical thing. So similar to what we have analyzed in big O notation, we can analyze big omega and big theta. What is big omega gives a lower bounds. We have seen the upper bounds of the function, but when we analyze big omega, we will get a lower bounds of the same function. I hope if you understand the upper bound functionality of big O analysis, you can do the omega analysis, and similarly theta also use both the upper bounds and the lower bounds of the equation. You can go through some of these resources. You can get these links from the PPT when the session is ended. I will upload this PPT and you will get those session. You can get those links and you can check the basic mathematics that are needed to analyze the complexity and different complexity analysis. You can study about the big theta and big omega things. This is time for question and answer. If you have any questions, please post it. I will break it for 5 minutes. I will be here, but the session will be continuing after the session will be continued after 5 minutes. You are supposed to ask any doubts. You can ask. This PPT. This is showed on this PPT. You send or mail. Venkateshwara sir, we can send
persons are not
PPTs to
attended.
every mail IDs.
That means one person.
Yeah.
Hello.
Hello.
Tell me, sir.
Hello.
Okay. If possible, you
Pardon me,
can
sir.
send mail.
Can you
If not, how
come back
to
to
see
me?
that information?
Hello. Yeah, I can hear you.
Okay. Okay.
Sir, we can send it, but if there are more people, then actually people are attending at different sections. Yesterday we have conducted one section. So
Just a
we
minute.
need to gather all
Wait for
email
it.
IDs and we need to send. In particular, if you want the thing, if you particularly want the PPTs, you
Emila.
can mail me on K Suresh. Can you note it? Sir, can you note it? Okay.
సురేష్ నవ్వద్దు 82 @
K
gmail.com.
Suresh
Okay, thank you. K Suresh
82
82 @gmail.com.
at the rate
Okay, Suresh. Thank you.
gmail.com.
No, not at all. We are very
Sir,
clear.
yeah, K Suresh 82. Yes, sir. You can send the mail. I can.
Okay.
Any doubts?
Okay. Thank you.
How far the session?
తెలుస్తుంది.
Do you think the slides are useful to you for the you or the students can understand the things? Okay. Thank you.
Sir. Hello. Sir. Morning. Good afternoon, sir.
Hello. Venkateshwara College.
Hello.
Ishwar College.
Good afternoon, sir.
Hello, sir.
Hello.
చెప్పండి. చెప్పండి.
Sir,
ఒకసారి మళ్ళీ చెప్పండి సార్.
I
అంటే
only attend this session.
గుడ్ ఆఫ్టర్నూన్.
Hello, sir. Good afternoon, sir. I am only attend this session, sir. Sir, the remaining
Hello, sir.
phone numbers
Good
are
afternoon.
there, but they are in classes, sir.
Hello, sir. Good afternoon.
Hello. Hello.
Okay.
Hello.
Okay.
Sir, the remaining 4
Okay,
persons are
sir.
there, sir, but they are in classrooms. Hello.
Hello. Sir, can you send this chat message? I'm not able to clearly hear you.
Hello. Sir. Hello.
Okay.
Hello.
Hello.
Sir, same problem, sir. This PPT is also please send.
చెప్పండి సార్ పర్లేదు.
This PPT is also please send my mail also, sir. Sir,
చెప్పండి.
this PPT is very
హలో
useful to us.
చెప్పండి సార్ పర్లేదు.
Hello.
Sir, you can you please take my email ID?
Sir, you.
Okay, sir. Okay, sir.
Okay, sir. Okay, sir.
Can you take my email ID?
Yes, sir. Yes. Okay.
K Suresh. Sir,
Okay.
I am typing it in.
Hello. Hello, sir.
చెప్పండి.
Okay, sir. Okay, sir.
సార్ మెయిల్ మెసేజ్ చాట్ మెసేజ్ లో పంపించాను సార్.
No doubt, sir. No doubt, sir. The session is very good, sir. Very nice. This this PPT is also very useful to us, sir.
ఓకే సార్, థ్యాంక్ యూ. ఎనీ డౌట్స్ అన్నారు? ఇంకేమన్నా ఉన్నాయా? థ్యాంక్ యూ సార్, థ్యాంక్ యూ. ఓకే సార్, థ్యాంక్ యూ. We'll start session in 3 more minutes. Please bear with me. Thank you. खाली क्रॉस मार्क क्लिक करें तो एक्टिवेट हो जाता है। क्रॉस मार्क क्लिक करें तो नीचे का ओके फाइन। Welcome back, sir. Now we study, not study, already most of the people know what array is. Just to give you a brief introduction what the thing is. Array is nothing but a basic data structure where we access the values using the indexes shown here. So basically array data structures starts with index from big O, 0, sorry, as in the last sessions. Indexes start with 0, and one main problem with array is like it should be given a continuous memory thing, so it is not randomly resizable. Let us look at a queue simulation. How it looks. Just a minute, sir. I will share the desktop. If you can see, so can you see the browser? Can anybody please reply that? Can you see the browser simulation browser window? Hello? Hello? So can anyone see can everybody see the browser window? क्या है भाई यहाँ पे ब्राउजर विंडो शेयर करा है, दिख रहा है तुम्हें देखना है ना? मैं पूछ रहा हूँ जब से हम सबको एक जने वहां पे रह जाओ। हेलो सर, कैन यू सी द ब्राउजर विंडो? प्लीज रिप्लाई टू चैट थिंग। ब्राउजर विंडो दिखो। Sir, can you see the browser? Okay, sir. Huh? Sir, we will look at the array simulation. Sorry for the delay. Let us consider an array. Just we will create an array now. We'll fill it with random values. If you insert a value, like I want to insert a value 10, where this value actually stored. So it will see that what is the empty slot in the array, and it will position it there. So how much time will it take to place this 10 at index 9? In most cases, it takes big O 1 because it is just get the index and places the value. If you delete, which value will be deleted first? So it will delete the value at the last. So this doesn't take more than big O of 1. If you consider the same scenario, with array size 11 and randomly filled array, if you want to insert a value like 10 at index position 0, what it will do is, it will place the index and it will move all the elements that are right to it to one position. Then it will place the value 10 in the 0th index. If you look at this, the array is filled with n variables. In this case, if it is filled with 11 variables, then you need to move all the 11 variables to the right to place the element at position 0, at index 0. So what does this mean? If you want to insert any value at a particular index, it takes a complexity that is related to its position, how many variables that needs to be shifted. So in the worst case, if you try to position the element at 0th index, then it will take complexity of n. In the early case, we have seen a scenario where the insertion and deletion can be done with a complexity of big O of n, big O of 1. Now we are seeing that it is big O of n. So if you delete it, similarly if you want to delete a value from 10, so it will find the position, delete, and it will move all the elements to the left. Now it's a reverse process. So here in this case also it will take big O of n in the worst case. So to eliminate this complexity things, we need to study some different data structures. Let us look at some advantages and disadvantages of array data structure. Coming to advantages, if you are positioning the elements at the last index of the array, then the insertion or the deletion will take a complexity of big O of n. And one more advantage of array is there is no need to store the address of the any elements. Like if you can store one address of the first element, you can get address of any element just by because the array, all the memory elements of the array is continuously allotted. So you can get any element's address by just knowing the first address of the array. So what are the drawbacks in the array? We have seen in the simulation that array, if you want to insert an element at a particular position, in the worst case, it requires big O and complexity. And one more disadvantage is you can't dynamically resize the arrays. So considering these scenarios, and we look at a scenario of what is the data structure that can be used to overcome these things. Like I'll share the desktop again. We can see the simulation. Hope you are able to look at the browser window. We will look at the array versus linked list scenario. First, here we consider a scenario. You are an entrepreneur, and you are going to start an organization of hosting spaces. So users will be requesting for the spaces, and you will be allotting the memory. If you consider you are using a array data structure for your organization, here you can see different memory blocks. This entire block is nothing but your memory space that you are going to sell for your customers. Then the first customer requests for 100 MB. You allocate 4 blocks. This is nothing but each block is of 25 MB. Then if the next customer comes and requests for, this is the new customer, if the new customer requests for 10 MB, you will allocate a memory for 10 MB. Then the same first customer requests for another 10 more MB. Then, so here the same first customer is requesting for a total of 1 10 MB. So in the case of array, you can't allocate this 10 MB somewhere and 100 MB somewhere. So you need to allocate 110 MB continuous memory. So you need to copy entire data what we have given into the new slot, and we have to give the 10 MB. So this will give the 110 MB for the first user. What is, you can see the disadvantage. You need to copy the entire thing, and we need to again reallocate, and we need to place the same content again, and we need to allot 10 more MB. This is the disadvantage of using array data structure in an organization. If you consider a linked list, the same scenario, the first user requests for 100 MB, you highlighted 100 MB. Then the second user requested for 10 MB, you highlighted 10 MB. Then the third user is nothing but the first same customer that have already requested for 100 MB. So he is again requesting 10 MB. Then you need to allot 110 MB. In the linked list case, you will see how it will be allocated. It will place 10 MB somewhere in the memory, and it will copy the memory address M6 to his previous already allocated memory. So there is no need of extra work of copying this thing and pasting it in another thing. So this is the main advantage of the linked list. So we can allocate, in this scenario, we can allocate any number of slots, and we can just we need to place the memory address at the end of the thing. So this is the basic working of the linked list. Now let us look at the linked list and its operations. Here basic operations in a linked list, if you can see, basic operations in the linked list are insert, delete and search. The advantage in the linked list is we can dynamically resize without copying, no extra overhead. One overhead that we need to take is we need to copy, or we need to have an extra memory space to copy this address. So we have some advantages and few disadvantages. We look at the operations of these linked lists using a scenario. Let us look at the scenario of linked list simulation. We have already studied that it has a basic operations like insert, delete and search. Let us look what happens if you insert into a linked list. So if you insert a value into linked list, it will allocate a memory location in the, if you consider this as a heap memory structure in your system, then you can see that it allocated a memory block. This memory block has an hexadecimal address of 0x9644, and it placed in the linked list. It places the value in the linked list. So if you try to insert one more element, what it will do? It will allocate another memory in the memory block, and it stores this address 0x1745 in the link. This is nothing but the link for the next node, next data. So it will store this address. You can highlight और आप इस तरह देखो वो memory highlight और black. So it stores this memory address in the previous already allocated memory, and just it links and keeps the value 34 in that node. The head is the position which is the starting point for the linked list. We can use this head to navigate the linked list. So if we try to insert another element in the linked list, so head will go last till last, and it will locate in new node and make a link, and head will be positioned in the first position. And now we have seen the insert operation. if I want to delete element, how would I delete? How would it will delete? See, in the array, look at the disadvantage of removing an element at a particular position. Now, if you want to remove an element like 34, which is at some, so we'll check, we'll clearly look by inserting another element. See, now we'll check the delete operation. If you want to delete element 34, which is located somewhere in the linked list, so what the linked list will do is, it will break the link from 12 to 34. It will copy this node to a temporary variable, and it will link the head.next node to its temp.next node. Let us look at it. See, it will check element form, so it will remove the link, and it will keep head.next to the next node of the deleted variable. So, you can see the advantage over array, because we are not moving any data, just we are reorganizing the links that already existing. Consider deleting 54. Now what it will do? It will remove this node and link it to the last node. Okay? Similarly, this is the advantage of the linked list, and we will look at the implementation of linked list. Let's look at the implementation of the linked list. See, linked list consists of different nodes. You can see the node. This is the node structure. We can create any type of node. Like here, I have considered one data variable and its next pointing address. Right now, I have pointed it to null because I am not pointing it to anything. So we can create a node with two data variables and one address next address pointing variable. So basically, this is the data structure, node structure. So how would a single linked list look like? See, single linked list. The first point for the single linked list is, as we discussed, is a head variable, and the next variable will be pointed as head.next, which is nothing but this variable, this node, and this doesn't point to any other node. So we will place in a value of null. So similarly, in the insertion part, if you consider this single linked list array, if you want to insert a value of 99 in between these nodes, then I will take a variable temp, which is also pointing to the head, and I will create a new node such that new node has the value of 99, and initial stage it will have a next pointing to the null. Then I will break the link from head to the next node. I will break the node because I already have temp variable. So then I will point the temp.next to the new node. Then in the next node, in the new node that I have created, I will point the address variable of the .next to temp.next. Before this is rotated, and then it will be linked to this 37. So we will be using this link, and new linked list is formed with values 22, 99 and 37. Suppose if you want to delete a node, what will we do? We will take a previous pointer which is pointing to head, and we will take a temporary variable which is pointing to the previous .next, that is nothing but this. Then we will say that previous .next is equal to temp.next. So it will point like this. Then we assign this temp value to null. By assigning this temp is to null, we can say that this element is created and the links are formed. So let us, this may be a bit confusing. We'll see implementation of this thing by looking at a scenario of inserting 10 random integers into a single linked list. If you people have a system to work on, please try to work on it. We have the framework of the code. I'll show it to you, which is also on the portal. You can download the framework and you can work parallelly with me. I will share you the code example. We look at linked list demo 1. Okay. Just a minute, I need to set the font thing. Is the font visible to you? Okay. Here we have a framework code which we have looked at the implementation of linked list by looking at animal simulation, and we have looked at it through some images. Now we will implement the code to actually look at how linked list work. See, we have seen linked list will be consisting of different nodes. For our example, as we are going to insert 10 random integers, we will take a class node of the structure of the node contains one data value and a next address value which is pointing to the next array. And we will create a class. This framework you can download it from portal. For your easiness, I am repeating it again. We have a class like linked list demo1 linked list demo1. So in this we have, as you look at the images, that we have considered different types of nodes like head node, temp node, current node. For my simplicity, I am considering these things, head node, temp node and null node, in my constructor, assigning these things to null value. And we will implement different functions like insert, display and remove. And there is a framework code which says main method which is having like a menu structure, like you need to select an option like inserting, removing and all those things. In this case one, where we write inserting 10 random numbers code, is I used a random generator, and random generator has a method extend below 100. This value specifies that I want a random variable between 0 and 100. So I call this insert method 10 times in this loop, so that 10 random numbers will be inserted at one time. So let us now implement the code for insert method. Like if first we need to check that if head is equal to null, equal to null. First we need to check that if head is equal to null. What we need to do? If you consider head is equal to null, what we need to do is, just a minute, there is a space. We will, as head contains null element, we will take head as a new node. We have created head as a null, but actually in the memory it doesn't create, haven't created any space for it. So we will take head as a new node to allocate some memory. Then head dot next. As it is the first element, I need to give head dot next equal to null. Then I need to place as insert memory insert function by calling, we are calling the insert function with a random integer. So we will get a data. So we need to put the data in the head is the first node, so we need to put the data in the head node. So head dot data is equal to data. Then as we also declared some nodes like current node. At this point I will explain why I choose current node. Current in my code, current node refers to the last element in the list, so that I can implement, I can insert the last node at the last position with big O and complexity. If I have not taken the current node as the last node, now I have to take the head node and I have to traverse all the list, till the last element. I need to place the element there and I need to move till last. So it again takes the length of the list. So it will be a disadvantage. So I am maintaining a node, current node, such that I can insert an element at the last with a big O of 1 complexity. So I have pointed the head node, so I have to move the current node to the last inserted position. My last inserted position is nothing but, here we need to declare it as a new node because it needs to allot the memory for this current node. Now I point the node, I point the current node to the head because last element I have inserted is in the current node. We may not need this because we are just pointing the current pointer to already allocated memory, that is nothing but head. So this case ends here because this is the first element that we inserted in the list. So we have created a node, head node, and we have kept the next pointing address to null and the data, some data in it, and we have pointed the current node to the last node. Then what if head is not equal to null? Then we will write the code in the else block. What we need to do if head value is not, the list is not, it is not the first node, then we will create a new node. As we looked in the images, we will create a new node and we will allocate the memory by creating it. New node type, this is of node type. So then we have created it. So new node dot, what do we say? Data is equal to what we have got the data, we will put in the new node. You are seeing that in the example we have put 99 in the new node. Similar, that is done as new node dot data is equal to what? The data. Then it is not pointing to any other nodes, so we will keep dot next equal to null. We have created our new node. Then we need to insert, I'm inserting it at the last position. Right now, what is the last position that we are pointing? Head or the current node? So we can't move the head because we need a reference point for the linked list to traverse. So we keep the head as current node is already pointing the last node. We use current node dot next. It should point to the new node. Should point to new node. Then, as you know, the current node should be at the last position. Still, we didn't move the current node, so we will move the current node to the new node. Please try to understand. It should be clear that first we are pointing the current node and its next address to the new node. Then we are moving the current node pointer to the new node. So current node will be at the last. So this ends the implementation of our insertion function. How do we know that our function is good and working? Just by displaying the things. So we will try to write the display function now. As we know that head is the starting point, we can't move the head. We will take a temporary variable pointing to head, Then I need to traverse through every node and I have to print so that I can see that all the nodes are inserted. So we'll have a while loop. Then we'll traverse through the thing till the last of the list. So we need to check that temp dot next. Last node will be current node, and the current node will be having a null value which is pointing to the next. So we will check the temp dot next not equal to null. If I think you are clear with this condition because we are assigning the temp to the head variable and we are traversing using a while loop such that temp is not equal to null till the end of the list. If you go to the end of the list, then your temp will be pointing to null, so you will get out of it. So what we need to do while traversing through the list? So here just we want to output what is the values that are inserted in the list. So let us look how do we print. So the point is the temp point is currently at head node. So we say that to get the data from the temp node, we will keep temp dot data. For linked list sort of display, I have kept some string so that we can clearly see how the linked list look. If you are not writing this is also fine, but for clear thing I have given this. For clear display, I have given this arrow strings. Then, once we display the content of the temp, we need to move the temp to the temp node, temp next node. Temp is equal to temp dot next. So, in this way, we will continue till the end of the loop. So, we will move till the end of the loop, but we will stop at the last node. So, to print it, I just write one more print statement. The last node is temp dot next, temp dot data. We just want to print the data. So, I will remove this LL because I want it to be in the same line. So, here I will print it the last data also, and I want it to be a continuous string. Then I just printed a blank new line so that for the clarity of the display. Now let us try to run this code and check does the linked list insertion is working fine or not. Let's go. Let us try to run the code linked list demo 1 Java C that is compiled. Linked list demo 1.java. It's compiled well. So let us run and see. Let me set the properties of this window. We will see the running part of the linked list demo 1.java. Here you can see a menu like 1 to insert elements, 2 to remove elements, 3 to display elements, 4 to exit. Here we already implemented a code for insert and display. Just we will insert the things and we will check the thing. 1. So insertion is done. To check our insertion function is working or not, we will display the list. See, you can see the list that 10 random numbers, head value at 70, pointing to 48, 48 pointing to 38, 38 pointing to 74, and so on till the last variable. So our code of insertion is working well, and the display is also working well. You can see a linked list type of view here. Now, let us try to implement a delete element at the last. For simplicity, we will delete element at the last. Let us look the display how to implement it as delete remove function. If the node is the first node, so if the head node has a null value, consider that you did not insert any values in the list. What does the head contain? It will contain a value of null, right? So in that case, you need to say what? The list is empty. So you will do it like you just print out one list is empty. You will just give that list is empty. Now, if the other condition we need to check is if we have one element, we have only the header. If you consider if we have only the head element. What we need to check is if head dot next it has only one element, so it will not be pointing to any value, so it will be having a null. If it is equal to null, then what we need to do is simply remove the head value. How do we do that? We just print the thing that we are deleting first, so that we can know what is the element that is deleted. So just printing the thing like head dot data. So as we deleted the node, so we need to make head to null because we just printed it and we haven't deleted it. By making it null, it will delete the node completely. So current point is also pointing to the current pointer which early in the insertion method we discussed that we are using the current pointer. So current pointer is also pointing to the head. When we deleted the head, so current point still exists. So to remove the current node pointer, we will make current node also null. We will assign the current node also to null. So now we completely remove that node. So we have checked two conditions like if the list has no elements, if the list has one element. Now we will check the list has more elements, which is the case that we need to consider, the remaining case that we need to consider. Here, first we can't move the head. Head is the starting point reference, so we can't move the head. We'll take head, we'll point the temp pointer to the head. Then we'll take a variable. We have looked at the image example of linked list. We are maintaining the previous pointer to have track of the previous node. So now we will declare a previous pointer. Okay. First of all, head is temp is pointing to the head. So previous. Let us take previous is pointing to a null because it's just initiated and we don't want. Then we need to traverse the list till the element that we want to delete. So what we do is we use a while loop that we have used in the display method. Temp not equal to current node. Current node is the last node for us. So I have shown that temp dot not equals to null in the last example. We used the current node thing here. So temp temp not equal to current node. See, it will move till the end. So if you move till the end, then while we traverse through the list, what we need to do is the delete operation. How will we do? Right. We will move the previous pointer to temp. No, we will move the temp pointer to temp dot next. So by traversing in this way, till the temp is not equal to, we are deleting the last node, so we consider the current node. So when temp reaches the current node, what that means is, we come out of the loop and the temp will be at the position of, temp will be pointing to the current node. So what we need to do is, the previous pointer is pointing to the previous of the temp. So we will use before just we will print out what is the element that we have deleted for our reference. Like last node is temp, so we will print temp dot data. So once we print it, so we can delete the temp node now by assigning current node. We want the current node reference to be there for pointing the thing. As current point is at the last node, we will move to the previous point because we are deleting the last node. So we have moved the current node to the pointer previous, which is one step before the temp position. So now we can delete the temp variable by we need to keep the previous dot next equal to null, so that it will release the link from previous to temp. Now, as we release the link, we can assign the temp to null. Okay, this is the implementation code for the deletion part. Now, let us check the same example. We need to compile it again. So, let us check the same example. Compile and run. Now, we can see the operation, different menu options like insert, remove, displacement. First, we need to, let us try delete an element without doing any insertion. Okay, that is one of the case that we have done, right? So I want to delete, remove. It says that list is empty, empty list. So it can't delete anything. So I need to insert values into it. So to insert values, I will give 1, and I inserted the values. Now I will check the inserted elements by displaying them. Yes. Now, if I delete an element, for me, it should delete the last element. Okay. So let us try the delete option. 2. So it says that it deleted a value of 24, and for our information thing, let us check it's really deleted, or the program is dropping us just by giving the displaying the last element. Let us look at it. Yeah, compare this list. The last node is removed. So the program, we can say that the program is working fine. So if you want to delete one element, just give one more 2. 69 is deleted. Check the list. Yes, it is deleted. So this framework of the course will be uploaded in the portal for your further work. So we will go to our section now. So we have looked at the implementation of inserting temp random integers into the single linked list array, and you have it's a time for you to work on some tasks, and in the section you need to work on one task. And we have other problem sets also, which we will be uploading into the portal, and you will get the things, and you need to work the remaining problems before the next session in the next week. So your first task that we need to work is this thing: implement a count. You have seen the example that I have done, right? So, if the values that we insert in the 10 random integers, if you have inserted 12 5 times, you need to implement a count function such that if you try to find the number of occurrences of 12 in the previous example, it should result in 5. In this example, it is 12 is resulted, 12 is, if you consider this list, how many times 12 appeared? It should be an output 2, sorry for this thing. And if you consider the input of 3, it gives a 0 because the 3 value doesn't exist in the list. So the count of 3 is 0. Similarly, if you consider a value of 42, occurrences of 42 in this list, your program should give an output of 2. So, kindly try to implement this task. The task needs to be done in 20 minutes, and we'll just you work out, and we'll carry on the session after 20 minutes.